over the evidence of a chemical change lab. So this document has been posted to Canvas. And so starting with the pre-lab that you were to do before coming to class on the day of the lab, we are writing and balancing our equations. And then you should also be able to identify what type of reaction everything is. So I wanted to start with the first reaction, this one that we have, copper 2 nitrate reacting with sodium hydroxide. You form copper 2 hydroxide and sodium nitrate. So I wanted to talk about how to determine what your precipitate is in this reaction. So using the back of your periodic table, we have our solubility chart, and the first product that we formed was copper 2 hydroxide. So if I look up hydroxide on this solubility chart, it is in the section that says insoluble, which means that hydroxide is usually going to be part of my precipitate. But just to make sure, I'm going to take a look at the exceptions. So remember that your exceptions will just do the opposite of whatever the normal section says. So hydroxide bonded to ammonia or an alkali metal cation is actually going to be soluble, but that's not what we have in this case. We have CuOH2. So it is copper bonded to hydroxide, and that is insoluble. So next to that product, I'm going to write S for solid, which means that that is the precipitate that is forming. And then NaNO3, just to make sure, I'm going to look that up on my solubility chart as well. And I have NO3 up here in the section that says soluble. And there are no exceptions to that. So my NO3 is going to form a soluble product every time. When we write on that, we would say AQ for aqueous, telling me that the aqueous solution that is formed should be NaNO3, and then copper 2 hydroxide is my solid. Both of these will still be present in the test tube when the next reaction is taking place, but the only reaction that we're concerned about is the one that includes the copper product. So that's why we took this and did the decomposition of copper 2 hydroxide. So starting with the chemicals that we needed, I'm going to start by measuring out some copper 2 nitrate. So I have this solution, CuNO3, and we need just 1 milliliter. So starting in number 1, I'm just going to read through the lab procedures with you. Fill the beaker. I already put the beaker on the hot plate, so that's going in the background, and I have my room temperature as well. So then, number 2, in a 10 milliliter graduated cylinder, we're going to measure 1 milliliter of 1.0 molar copper 2 nitrate. So 1 milliliter. Remember, you need to get down to eye level to be able to actually see where the bottom of the meniscus is when you're reading this. So 1 milliliter is a really, really small amount. When you're holding it like this, it might kind of wiggle, it might tilt a little bit, and you can't tell very well. So you have to actually get down to eye level to do that. And then in a separate graduated cylinder, in another graduated cylinder, I'm going to use sodium hydroxide. This kind of confused a lot of students because the molarity is listed on your lab. So this one says, in another graduated cylinder, measure 1 milliliter of 3.0 molar sodium hydroxide. That 3.0 M tells us how strong the sodium hydroxide is, but that is not a volume. The volume is still going to be 1 milliliter. So we're going to have equal amounts of sodium hydroxide and copper 2 nitrate. So then put my milliliter in here. Again, getting down to eye level just to make sure that the bottom of the meniscus is where it's supposed to be. So, equal amounts of each of these solutions, very, very small amounts, they're both 1 milliliter, and then I put them together into my test tube. So I'm putting my sodium hydroxide first, and then I'm pouring my copper 2 nitrate. And instantly you can see a color change here. So it goes from kind of a lightish blue to a darker blue. So we have a dark blue color. It started as kind of a light blue, so it might not be as dramatic of a color change as some other things. It kind of looks like it might be the same thing. Definitely on camera it's not translating as that different. See if the white background helps. They definitely look similar colors, but in person you can tell that this one is slightly darker. So that is what I would record for my observations here, and then as I sort of swirl it around, you can tell that it's also getting chunky. So I'm just going to take my stir rod and mix this up so you can kind of see the quality of that. So it's like definitely chunky, clear, solid formed there. And I'm going to take this whole thing and I'm going to place it into the hot water bath. So you can kind of see some steam already starting to form there. This is going into the hot water bath. So as far as our observations, while this is in the hot water bath, I'll go back and kind of fill in. So pick up the test tube and swirl it around to mix the solutions together. You may use glass stir rod to ensure the solutions are thoroughly mixed. So our observation for number 4, I would say, is darker blue and chunky. Chunky precipitate. Part of the reason that I wanted you to get your reactions listed out before the lab is so that you could actually tell me what the precipitate was that was formed. And so based on the reaction that we predicted, we said the precipitate itself would be CuOH2, and then the aqueous solution would be NaNO3. So based on what we saw, you should be able to tell me the qualities of the aqueous solution. So sodium nitrate, what would that look like versus copper hydroxide or copper 2 hydroxide? So that is okay for your observation, but when you think more in depth about your analysis, you should be able to tell me specifically which one was the chunks and which one was the aqueous solution. And then it says touch the bottom of the test tube. I forgot to do that part, but I did not notice a temperature change, so I'm going to go ahead and write none noted. So touch the bottom of the test tube, none noted for that one. Then on to the next page. So we are already at number 6. Our solution is heating right now. Place the entire test tube into the hot water bath, and within about 2 minutes, a significant color change should occur. So this has been heating for definitely less than 2 minutes, but if I keep stirring it, clear color change. That is like a dark, kind of like black-brown solution. So I'll hold it up against the paper, that way you can see. Definitely dark, so I'm going to go ahead and turn off my hot plate, unplug it, and then let that water cool down. Meanwhile, I have a room temperature beaker of water, so I'm going to just toss that in there. We'll keep an eye on it. So the observations are that solution turned very dark. I'm going to say like black-brown. I could not tell at first glance if there was a precipitate in there based on the reaction that just took place. So we did heating of copper 2 hydroxide, formed copper 2 oxide, and water. So as it sits right now, I don't see any water. So what you're kind of looking out for is knowing that water is a clear solution. If this is just sitting here, I don't see water in that. It kind of just all looks dark. But the longer it sits, maybe I will see some water. So I'm going to let that just sit there, finish cooling off. And the black stuff does kind of look chunky. So we'll see. So it looks like the copper 2 oxide is likely a solid. And then we'll just keep on waiting here. So one of the observations that a lot of students, I think, are kind of missing because they're going too quickly at this step, I just dry off the bottom because that's just some water on here. If we're super careful with this, and then hold it up against a dark background, I'm not sure how well that will translate. Let's see. You can actually see the separation of the layers in this, and so it looks like murky water. Let me get on the camera and see. Okay, yeah, you can see through part of it. So part of what was produced, I wish we had light. Part of what was produced definitely looks like it's turning clearish up here, separating from the darker precipitate at the bottom. Or I guess it's a little bit of a misnomer to call that a precipitate. And the longer it sits, the more you can actually see those layers separating out. So you can see that clearly we have water being produced. So you see that clear layer on top of the darker precipitate. So we continue to stir it, which keeps it kind of muddied, but once it has time to settle and actually sit there, once you have your observations recorded for that part, we are going to add to that our 5 milliliters of hydrochloric acid. So I already measured this one out. This is another clear solution. I'm going to go ahead and just pour that into my test tube and continue to swirl, mix, swirl, mix, swirl, and literally right before your eyes, you can see a dramatic difference in this. So this is where we have created our copper 2 chloride and water. So it's basically just watered down copper 2 chloride or diluted copper 2 chloride. This is an acid-base reaction, so we put acid into it, and then it ends up breaking down into water and something else. Don't know why I put that back in there. I'm going to dry it off and put it in here. And then I cut already a little piece of aluminum foil, so it's about that same size. It's a little bit different. It can be slightly bigger, slightly larger. It doesn't slightly. The aluminum foil can be slightly larger or smaller. Sorry. And so I'm going to go ahead and just drop that right into the test tube. Mine's a little thick, but that's fine. I'll just kind of shove it down there. So letting that sit. And I'll hold this up so that we can see what's happening. So it said swirl it. I'm going to let it actually kind of take its course for a second. That way you can see on the video what's occurring. So right away I see bubbles, which tells me that a gas is produced. And so this is something that I wanted you guys to see in terms of the error that you're talking about. If I have copper 2 chloride reacting with aluminum to produce aluminum chloride and copper, no part of that should be a gas. So aluminum chloride is not a gas, copper is not a gas. But we also know that we have other substances that are still present in this test tube. So part of the reaction could be from that. Part of the reaction could be from other components that are a part of the aluminum foil, since we know that aluminum foil is not 100% aluminum. So in the directions it says to continue to swirl it, you can mix it and then tap the side of the test tube with your fingers to kind of knock the stuff off of the aluminum. So definitely lots of bubbles in here. You see some foaming. It's almost like a rusty sort of color, but this is not rust that's forming. So students who are saying that they observe rust forming are incorrect, because rust is made of iron and there is no iron present in any of this. If I touch this, it is getting noticeably warmer, so it's not correct to assume that because you see bubbles it's warm, but feeling it, definitely note the temperature change. So just continuing to let this react. I'll put it here and kind of just let it go. At your desk only, yeah.
So basically we're just for the balance,
Just like
right?
go to a different one so you're not next to their table, yeah.
Write the balance equation too. We're just rewriting what we did here, right?
Yes, that's correct. Alright, so checking on the product again. If I continue to tap this, so the aluminum foil has completely changed into this kind of rust red color. So I no longer have any silver foil left. I have only this, which is my copper product. So just copper at the end, which tells me that my aluminum chloride, plus everything else that was in here, is kind of like a light bluish, clearish color, and then my copper is what the reddish solid is at the end.